Okay, you ready?
Yeah.
And who's gonna film? Cool. So here we go. If I have this, that's the creepy thing that your thing does, right?
Yes.
No. If I have this, you recognize it as a system of equations for linear equations, right? They're both lines. So if I tell you to solve for x and y, you know you're finding the point of intersection. And if I have numbers, you would do elimination, right? Let's do elimination with variables, shall we? What do you get? We get, I don't have to multiply, what?
Both of them.
The top, let's start, I'm gonna solve for x, so for y. Let's do it for b, so I can find x. I'm gonna multiply this one times b2, and this one times negative b1. Do you agree? So I would get as a result, what would I get as a result?
B2, A1.
B2,
A1,
X
plus b2, b1, y equals b2, c1, right? Is this what they're doing? Tell me that's what they're doing. Yes. And the bottom part, I would get negative b1 a2x plus minus b2 b1 y equals negative b1 c2. Okay? I eliminate this one, and I am left with
B2A1X minus B1A2X equals B2C1 minus B1C2.
Okay, perfect. Is somebody lost so far? Or we're all good? Okay. So now I'm solving for x, so naturally I have to take the x out, right? And I've got B2A1 minus B1A2 equals B2C1 minus B1C2. So nothing weird there. I divide both sides by B2A1, so I leave the x by itself, and I've got B2C1 minus B1C2 over
B2A1 minus
B2A1 minus B1A2. And that is my formula when I have this. If you have it in your notebook, all you have to do when you have a system of equations is just plug in the numbers here and you'll find x. Okay? Pretty simple. I believe you are capable of doing y. I'm not going to do y. I would just copy it off example 66.1 and put it in my notebook now that you understand how to do it. Okay? We good there? Questions on that one? Because we're going to go into a completely different topic. Okay. You good, Steve? Pretty easy, right? Just your basic algebra, which I know you're extremely good at. So, may I erase?
Yeah. Wait. What about if you do?
The formulas are in the notebook, in your book. Okay? You ready?
There's no one formula with that one.
There's an x, and on the other page, if you continue reading, you will find the formula for y. Not kidding. It's there. Trust me. Next page, it's there. Okay. So, let us continue. Phase shifts and period changes. Ooh. Phase shifts and period changes. Okay, so last time we saw that phase shifts let's say that y is normally sine of theta. Sine theta starts, this was 90, 180, 270, 360. This is just a review. Sine, and this is 1 minus 1. right? And you remember that if we shift it, let's say that we put a y equals sine of theta minus 90, then it starts at 90. It starts here, so it shifts,
90.
and it would end up at 450, right?
Mm-hmm.
Right? And if I put y of sine theta plus 90, then I would start back here. This would be,
90.
I would start back here because I shift it 90 degrees, right? Like this. Is that clear? Right? I shift back here. So far, so good? Okay, now, I also remember that if I have I'm going to do it with cosine this time. Y equals cosine of theta. It was, to do this no matter what, do it. 1, 2, 3, 4, 90, 180, 270, 360, 1. With cosine, I would start here. I start up here, I go down here. That's my cosine, right? And if I put, my period is 360 degrees, correct? If I have to do y equals to 2 theta, what would happen? Everybody remember? I have to fit 2 of these into 360, right?
Mm-hmm.
So I would have to split this up so that I can fit 2 of them. I would still start here, but then I'd have to go like this, right? I've got one here and another one here, correct? And if I have a 3, well, I have to fit 3 of them in there. And if I've got a y equal to cosine 1/2 of theta,
You have to do half of 1 and 1.
it's only half of 1 in 360, right? So that would be like this, right? And this would continue all the way to here, all the way up to 720. Okay? Do you remember this? Now we're going to combine the 2. Okay? So I'm going to erase over there, even though that graph is like really beautiful.
No, why not? No.
And I am going to get, besides really dirty in my hands, I am going to get, let's say they give me this. Y equals sine of 2 theta minus 90. This, remember, is called the argument, right? Remember that? Just in case you forgot, I'll remind you. Argument. And obviously it represents the angle and how much it shifts, right? I'm going to factor that, and I'm going to have sine equals 2 theta minus 45. So what do you notice right off the bat?
It's similar.
It's the same thing was over there. You've got a period of a 2, which means that you're gonna have 2 of these fitting into 360, correct? Because you've got a 2 right here. And it's shifted 45 degrees, right? So, 1, 1. Does everybody understand what I did here? It's really, I mean, nothing weird. If it's shifted 45 degrees, it means, all right, what is my center line? 0, okay. My amplitude? 1. My, well, the function, you know, it's sine. Phase shift? 45, plus 45, right? So that means it's going to start on this side. And the period? 180, because it's 360 divided by the coefficient, right? And that's 360 divided by 2, 180. Is that clear? Okay. So, what that means is I start at 45, and for one full one, I'm going to end up where? Plus 180, exactly, because that's my period. So, this is going to end up in 225. Did everybody understand how I got the 225? Yes? I start out at the 45, which is my phase shift, and I have to add the period to get one full one, okay? If I were to do it, if I were to add 360, I have to do 2 full ones, okay? But I'm only going to show 1. So, 45 to 220, this is 180. 180 divided by 4 is 45, so this is going to be 90. 135 and 180, right? Right? So I can draw. Got this here. And it's sine, so. Okay. Now, positive or negative? Positive, so it goes up. And I'm doing it here. Oh, what a beautiful sign. Perfect. Okay? If you want to get all fancy, you can continue down here. But you don't have to. Just showing that you know what you're doing, where you're going. Okay? Is it clear what I did? Yeah? And I believe that is it.